All right, we've been given that P of Z is equal to Z cubed plus BZ squared plus CZ minus 87, where B and C are both real numbers, and P of negative 2 plus 5i equals 0. Determine the values of B and C. Now, a couple of important things we've been given here. Firstly, we've been told that B and C are both real numbers, so our coefficients of Z squared and Z in our polynomial are both real numbers. And we've been given that a complex number, negative 2 plus 5i, is equal to 0. Now, if we've both got real coefficients, then we can use our conjugate root theorem that says if I've got a complex root, then I know that another root is actually also the complex conjugate of that root. And I'm going to need to use that information to help me to solve my unknowns. All right, so I have got that P of Z is Z cubed plus BZ squared plus CZ minus 87. And I've also been given that P of negative 2 plus 5i is equal to 0. And I could therefore say by the conjugate root theorem that P of negative 2 minus 5i is equal to 0 as well. Now, because this is a cubic polynomial, I know that if I've got two linear roots, my third root must also be linear. So let's state that. So P of Z is cubic, therefore I have 3 linear roots. And the importance of this is that I can actually write this Z cubed plus BZ squared plus CZ minus 87 in factorized form. Okay, similar to what you would do with the cubic methods, where you would say y equals a, x minus x1, x minus x2, x minus x3 when you're writing it in x-intercept form. We can do the same thing with this complex polynomial. And one of my roots is this one of my roots is this one, and a third one is an unknown one that we're going to find. So I'm going to write this as P of Z is equal to Z minus negative 2 plus 5i, Z minus negative 2 minus 5i, and Z minus a, where the Z minus a is my third linear root. I don't have a coefficient in front of my Z because I can see in my original equation I have a coefficient of 1 in front of my Z cubed. So that means that when I expand this, I actually only want a coefficient of 1 in front of Z cubed. So I know that I've got a coefficient of 1 in front of that Z. All right. Let's just tidy this up a little bit. So I have Z plus 2 minus 5i, Z plus 2 plus 5i, and Z minus a. When I'm introducing a variable, I want to say that a is a real number, and up here we wanted to state that B and C were also real numbers. Okay. I'm now going to expand these brackets. I'll start with the complex side of things. So we'll start with our first two brackets, and I've got Z squared plus 2Z plus 5iz plus 2z plus 4 plus 10i minus 5iz minus 10i minus 25i squared multiplied by z minus a, and that can be simplified nicely because 5iz minus 5iz plus 10i minus 10i, those will add, and that I squared will become a -1, and I end up with P of z is equal to z squared plus 4z plus 29 times my z minus a. Then I'm going to expand that, so I get that z cubed minus az squared plus 4z squared minus 4az plus 29z minus 29a. And now what I'm going to do is I'm going to collect my terms that belong with my z squareds, my z's, and my constants, so that I have z cubed minus a plus 4 z squared. Okay, I want to change that sign over there so that I can minus a minus 4z squared plus 29 minus 4az minus 29a. Now you're wondering to yourself, why have I done that? Well, let's have a look here. I've been given that P of z is equal to z cubed plus bz squared plus cz minus 87. Well, P of z is also equal to z cubed minus a minus 4z squared plus 29 minus 4az minus 29a. So that means that this whole thing must equal b, this whole thing must equal c, and that whole thing must equal to 87. Okay, so let's say that we've been given that P of z is z cubed plus bz squared plus cz minus 87. So I can equate coefficients. Okay, so therefore I know that b is equal to negative a minus 4. I know that c is equal to 29 minus 4a. That's going to be equation 1, equation 2, and negative 29a is equal to negative 87 is equation 3. And from 3, I get that a is going to be 3, and then I'm going to substitute a equals 3 into both 1 and 3. So b will be 4 minus 3, which is 1, and c will be 29 minus 4 times 3 equals 17. Okay, it is a little bit quicker to do it with your calculator because we can use our calculators to expand our complex numbers, and that then means that we can just equate it as real and imaginary, and we can do it a little bit faster. Let me show you. If I have P of z is z cubed plus b z squared plus c z minus 87, and I've been given that p of negative 2 plus 5i equals 0. Okay, I know therefore that minus 2 plus 5i cubed plus b times minus 2 plus 5i squared plus c times minus 5 plus 5i minus 87 is equal to, now I can write 0 as a complex number, and I can write that as 0i plus 0j. So not 0i plus 0j, 0 plus 0i. All right, and I can use my calculator to expand negative 2 plus 5i cubed, negative 2 plus 5i squared. And I know you're thinking to yourself, why is she doing that? But what we're going to be doing is then looking at our real and our imaginary components. So using GDC to expand, what I get is 142 minus 65i plus b times minus 21 minus 20i plus c times negative 2 plus 5i minus 87 is 0 plus 0i. Okay, now I'm going to collect all my real and imaginary terms. So that I have 142 minus 21b minus 2c minus 87 plus negative 65 minus 20b plus 5c. I is 0 plus 0i. And now I can equate my real and imaginary components. And this is where the beauty of this comes in, because 142 minus 87 is 55. I'm going to have, let's write it out, 142 minus 21b minus 2c minus 87. Those are the real components. That's equal to 0. So I have 21b plus 2c is equal to 55. And if I equate my imaginary components, I'm going to have 5c minus 65 minus 20b is equal to 0. And so I have negative 20b plus 5c is equal to 65. Now notice I have written this so that my b's are one under the other and my c's are one under the other, because I'm actually going to use my GDC's equation solver. So the simultaneous solution solver. So using GDC, simultaneous equation solver, and lo and behold, we get the same answer.